We're going to work on a three-part piecewise function in part 3 of this section on graphing functions. So I'll go ahead and highlight these. We're going to graph the first function on the interval that is less than -4. We are going to graph x cubed on the interval between -2 and 2. And we are going to graph the last function, x, on the interval greater than or equal to 2. So there are the intervals. There should be a gap between -4 and 2. For the first function, we have a shift to the left by 6. And I'm just going to put an arrow to the left 6 units. And we also have a shift down by 4 units. Now, you haven't seen too much about function shifting. However, if you wanted to graph these, you could always substitute -4 into the function. That would be where your hole in the function would be. So at -4, you will have an open dot. That would be -4 plus 6 quantity squared minus 4. So that would be at 0. So I'll go ahead and put an open dot there. I know that this is going to be a parabola because of the square. And I know it's been shifted to the left 6 and down 4. So that would be the lowest point or the minimum on the parabola. I could also substitute f of -5. That would give me -5 plus 6, quantity squared minus 4. So 1 squared is 1 minus 4, so that will be -3. And so hopefully you can kind of see how this parabola would look. And since parabolas are symmetric, we can just count over and complete this parabola. For the interval between -2 and 2, we have an x cubed. At 0, x cubed would be 0. At -1, x cubed would be -1. At +1, x cubed would be +1. At -2, our x cubed would be -8. And at +2, our x cubed would be +8. If we connect these dots, we're going to get a function kind of like a bent paper clip. I've heard it explained that way at least. And if you look at the end points, I'm going to have to make those open dots. And then anything greater than or equal to 2, well, I can substitute 2 into the function, and I will get 2 out. Since we are including the endpoint, I'll go ahead and fill in the dot at 2. And then it continues up, so if the input is 3, the output is 3. And if the input is 4, the output is 4. Input 5, output 5. So it's just this line, the line y equals x. And that's anything greater than or equal to 2. So this is the graph. You could sketch this by hand, but let's say you wanted to double check your work in your calculator. There are going to be intervals and then the rule, plus interval and then the rule. So let's start with the first interval. The first interval is x is less than -4. Type second test. Arrow down to less than. Make sure you select the little negative symbol here, -4. close parenthesis, and now open a new set of parentheses and put the rule in. The rule says x plus 6 squared minus 4. Now we're going to add the next interval. Notice that the next interval is within two others. So it's kind of like it's sandwiched in the middle, and we have to write it slightly different. We have to use an intersection or an and symbol, and we'll use a logic symbol for that. I'll show you how to enter that. We have x is greater than -2. If we circle this part here and read from the x toward the number, x is less than x is greater than -2. So I'll type that in first. X is greater than -2. And now we're going to say second math logic, and we're going to put an and there. And then we will say x is less than 2. Then close parenthesis. Now we're going to put the rule in. The rule is x to the third. And you have to sometimes arrow down from the exponent. I forget that every once in a while, but it's a common error. X cubed, and then plus the last one. The last interval is x is greater than or equal to 2. So greater than or equal to 2, close parenthesis. And let's see what it looks like. What's our rule for this one? Just an x. So that's pretty quick. So if we compare the two, we can see that they're fairly close to the same shape here. So you can be pretty sure that you did this graphing correctly by hand. You should be able to do both graphing it on the calculator and graphing it by hand.